Hey guys, so this is video 2 on properties of exponents for Monday. So we just did in video 1 the product rule. If you didn't watch video 1, you're in the wrong spot. You need to go watch this and take your notes on page 31. So now we're on property number 2, which is the quotient rule. So just a recap, quotient means we're doing what operation here? Good, so our terms are going to be dividing. And there's something special we're going to do with our exponents. So just to recap, exponents are not actual numbers. They're an index. So you can't just do whatever operation the problem is doing for an exponent. It's got a special rule, okay? So the quotient property says if you are dividing two or more terms with like bases, or with the same base, I think we said same in the last video, with the same base, because remember they have to be like terms, then you subtract. So I want you to think back before we even finish this. The last rule was product, which meant multiplying, and when we multiplied, we added the exponents. Okay, quotient means divide. Isn't dividing the opposite of multiplying? Yes. So when we multiply, we add. Dividing is the opposite of multiplying. So the opposite of adding is to subtract. So we're going to subtract the bigger exponent minus the smaller one. And locate / write the answer where the bigger exponent came from. So the wording for this is really long and tricky. Other teachers don't necessarily do it like this, but this is what I did like my whole grad thesis on, everything. So I got you on laws of exponents, but this is the fastest way. So if you learned a different way in middle school, this might seem different, but I'm telling you this is the fastest way, especially when you get to math 2 and math 3, okay? So if we are dividing 2 or more terms, so let me give you guys an example like I did last time so you can see it, okay? Let's do x to the 5th over x to the 3rd. So we're dividing 2 or more terms, right, with the same base. So I'm going to go ahead and highlight that. We have to be dividing with the same base. Then we can subtract the bigger exponent minus the smaller one, and the answer goes where the bigger exponent came from. All right? So this is why it works. I want you to watch this, all right? X to the 5th means I have how many x's multiplying together? 5. That's what that index tells us, right? That means there's 5 x's. Now, x to the 3rd means I have how many? 3. So this would be 3 in the denominator, right? Remember, the top of a fraction is the numerator, the bottom of a fraction is the denominator. Are y'all good there? So watch this division. These 2 x's cancel. These 2 x's cancel. These 2 cancel. How many are left? 2. So our answer here is x squared. And for this one, they're both in the numerator, right? So underneath the x squared is an understood 1. Do you have to write that? Because there's nothing down here. So remember, it's like an understood 1. Remember when we did rate of change or slope? Do you have to write the 1? No. So this is my final answer right here, just x squared. Okay? So this is why you put it where the bigger one came from. We just did the long way, so here's the short way. We just did 5 minus 3, which is 2, but the bigger one was in the top, so that means x squared is going to be in the top, okay? All right, let me show you with another example. So let's do, I don't know, let's do y to the 3rd over y to the 7th. Okay, So what this means, if we did it out the long way, I have 3y's multiplying together in the top, and I have 7y's multiplying together in the bottom, or the numerator and denominator, right? So check this out. One set will cancel, right? Another pair will cancel. Another pair will cancel, and how many do we have left that didn't cancel? 1, 2, 3, 4, but this time they're in the denominator, okay? They're in the bottom. So what do we put on top? Same thing as up here. It's an understood 1. But this time the 1 is really important because it's in the numerator, so you do have to write it. So this would be our final answer, okay? So shortcut, 7 is bigger than 3, so 7 take away 3 gives me 4, but they go where we originally started. So the 4y's will go in the bottom, in the denominator, all right? So let's see if we can do a couple of examples using this property, and then you've only got one more for today. All right, example 1. Let's do, I feel like we can step it up. I'm going to go ahead and step it up. 6a to the 5th over 2a. All right, so same thing with what we did with the product rule. With the quotient rule, the numbers out front are just coefficients. So they do whatever the problem's telling us to do. Well, this problem is telling us to divide. So 6 divided by 2 is going to give me a 3. Now this is what's important. That 3 is in the numerator, right? 6 divided by 2 gives you a whole 3. Okay, so we can just put 3. Now, I want you guys to check out your A's. We're dividing, which means we're going to subtract our exponents, right? Subtract the bigger minus the smaller, as long as the bases are the same. So they both have A's. This one has an exponent of 5. What's the exponent for this one? Good, it's an understood 1. So the bigger exponent is the 5. The smaller exponent is a 1. So that means my answer is going to end up in the top, okay? So 5 take away 1, 5 minus 1 gives me 4. And remember, both of these would be in the top because they are a whole 3 and a whole a to the 4th. So my answer here is just 3a to the 4th. Don't worry if you're like, this is kind of weird. We're going to do a couple more, okay? All right, example 2. Let's do, can I add in another letter? I feel like I can add it in. I think y'all got it. We'll do 4a squared. I'll actually do that next time. Over 8a to the 9th. All right, so let's take a look at this one. Same thing we did with example 1. The numbers in the front are plain old numbers, and that literally says 4 divided by 8. Now, I'm going to talk to you guys about this one. Can we do 4 divided by 8? Can I take 4 pens and split them up between 8 people? No, people would have to share, right? So 4 over 8 we can't divide, but it does reduce. If you divide both of them by 4, then you get 1 over 8 divided by 4 is 2. So 4 over 8 reduces to 1/2 because 4 divided by 4 is 1 and 8 divided by 4 is 2. They both can go into 4, okay? Now, I want us to take a look at our A's because we're done with our coefficients. So look at your variables. Are they the same? Yes, they're both A's, right? Are we dividing? Yes, we already established that. So I'm going to take the bigger exponent minus the smaller one, and I'm going to put the answer where the bigger one was. So look at your two exponents, 9 and 2. Which one is bigger? 9, which means the rest of my A's, the ones that don't cancel, are going to be in the denominator, in the bottom. So now, what does 9 take away the 2 that go away? 7. Okay, so my answer for this one is just 1 over 2a to the 7th. All right, let's do one more, and I'm going to have you guys try this one. And then we will move to our last rule for today. So let's do 18. All right, I want you guys to try this one. So I'm going to give you about a minute or so. Try it, and then we'll go over it, okay? All right, so let's go ahead and take a look at this one. I gave you about a minute. So first I'm going to deal with my numbers out front, my coefficients. 18 divided by 3 leaves us with a whole 6. Now that means the 6 would be in the numerator, okay? Because there's nothing underneath it. It's not a fraction. It's just 6. All right? So now I'm going to move on to my x's. They have the same base, and we're dividing, which means we subtract the exponents. Good, because we're taking something out, so we're subtracting. Now, this bottom x doesn't have an exponent that we can see, which means it's an understood 1. So where are your x's larger? X to the third is bigger, right? So my bigger exponent is 3, which means my x's will remain in the top, and 3 take away 1 is 2. Okay, now let's go look at our y's. We're dividing, and we have the same base, which means we're going to subtract our exponents. Where is our exponent bigger? Where's our bigger exponent? 11 or 5? 11, and hopefully I think I heard even people in here answer me. It's in the bottom, right? So that means my y's are going to stay in the bottom because 11 is larger. 11 take away 5 is 6. So your final answer is 6x squared divided by what else we can do here. Because